In the next slide, we have the definition of isotopes. As we all know, the isotopes, which are elements which are having the same number of protons, that is atomic number is set. The same number, they will have the same number of protons, same number of atomic number, but having different number of neutrons. They will have different number of neutrons. Okay, so they, what will be the output is that they will have different mass number. They thus differing in the atomic weight of mass number A and also in physical chemical properties. Okay, as I said earlier, they will produce based on the chemical reactions of atoms and molecules by electron bombardment, etc. And they emit what? Why are they essential? Because they emit alpha, beta, gamma radiations. Okay, the what is called radioactive disintegration is that the rearrangement in original nuclide called daughter or decay nuclides are produced by radioactive disintegration. This process of nuclear change is known as radioactive decay. The radioisotopes, because they are not stable, because of their instability, they undergo radioactive decay. They undergo radioactive disintegration to attain stability. So during this process or during this radioactive decay, they emit alpha, beta, gamma radiations. Okay, during this radioactive disintegration, they emit alpha, beta, gamma radiations. This is known as radioactive disintegration. The main point to note is that because they are unstable or because of their less stability, in order to attain stability, in order to obtain a more active, a more stable radionuclide, they undergo radioactive disintegration to produce or to emit this alpha, beta, gamma radiations. Then that process is known as radioactive disintegration or radioactive decay. While this process, they emit alpha, beta, gamma radiations. Okay. This is the example of, these are the examples of isotopes. This protium, deuterium and tritium are all isotopes of hydrogen, etc. We all know this isotopes of carbon are carbon 12, carbon 13 and carbon 14. Okay. Next is the stability of radioisotopes or stability of isotopes. Stability of isotopes, they remain stable because of the ratio of protons and neutrons. Because of their ratio of protons and neutrons, this isotopes become stable, or the isotopes remain stable because of the correct ratio, favorable ratio of protons and neutrons. For example, the stable ratio of potassium is 1 is to 1.115. That is the ratio. Means proton will be 1 and neutron will be 1.115. That is a favorable ratio. And any change in this ratio, that is if one proton is added or one proton is removed, that will alter the stability of this radionuclide. Okay, that will alter the stability. So what happens? The neutron number should not be altered, or the proton or neutron ratio should not be altered. That gives stability to the radioisotopes. And many isotopes with elements with atomic number equal to or greater than 83 are considered to be stable isotopes, naturally occurring or artificially prepared, and the elements with atomic number greater than 83 are unstable. So that means isotopes should have atomic number less than 83. Okay, this less than 83 atomic number, this isotopes which are having less than atomic number 83 are considered to be stable, and greater than 83 are considered to be unstable. Okay. Here, in the next slide, we have the discussion of the radioactivity. That means the radioactivity, as I said earlier, what is radioactive disintegration or radioactive decay? This radioactive isotopes undergo radioactive spontaneous decay or spontaneous disintegration to attain stability. Because they are unstable, they undergo radioactive decay or radioactive disintegration to attain stability by emitting this alpha, beta, gamma radiations or emitting this radiations. to attain the stability. That is known as radioactivity. And there are different types of radionuclides based on the source of this radioisotopes. They're classified into natural radioactive nuclides and artificial radionuclides. And this natural radionuclides from natural source they are obtained. That means from they are occurring naturally, and artificial radionuclides means they are synthesized artificially. In case of natural radionuclides, there are two types, means high atomic weight elements and moderate atomic weight elements. In high atomic weight elements are uranium and radium, and in moderate atomic weight elements is potassium and rubidium. And artificial, as I said earlier, they are produced synthetically or artificially or synthetically synthesized to produce the desired radioactivity. Okay. Next is the characteristics of radioactivity. That means there are types of radioactive decay. As I said earlier, this radioactive isotopes emit alpha, beta, gamma radiations based on their radioactive disintegration that they are undergoing. And there are different types of radioisotopes. There are X-rays and alpha, beta, gamma rays, all different based on their properties. And there is a term called rate of decay. Rate of decay means half-life, T half. You might have already learned about T half. That is rate of decay. It is defined as the number of radioactive nuclei actually disintegrating or decaying or mutating in a given time. Means number of radioactive nuclei actually disintegrating or they are undergoing radioactive nuclei in a given time. Okay. Radioactive isotopes decays at the same rate, emitting radiations or particles at a time or conditions. Okay. Half-life, as I said earlier, that is the time required by a sample of nuclei to decay or the radioactivity to reduce by half of its original value. This is the time required to decay or the radioactivity to reduce by half of its original value. That is the T half. Time required for the radioactivity to reduce to half. ഇപ്പോൾ ഫുൾ റേഡിയോആക്ടിവിറ്റി ഉണ്ടെങ്കിൽ എത്ര റേഡിയോആക്ടിവിറ്റി ഉണ്ടോ അതിൻ്റെ ഹാഫ് റേഡിയോആക്ടിവിറ്റി അല്ലെങ്കിൽ ഹാഫ് റേഡിയോആക്റ്റീവ് ഡിസിൻറ്റഗ്രേഷൻ അച്ചീവ് ചെയ്യാൻ എടുക്കുന്ന ടൈമാണ് ഹാഫ് ലൈഫ് എന്ന് പറയുന്നത്. So it is unique for each radioactive nuclide. ഓരോ ന്യൂക്ലിയഡിനും ഓരോ റേഡിയോആക്റ്റീവ് ന്യൂക്ലിയഡിനും യൂണീക്ക് ആണ് T half എന്ന് പറയുന്നത്. ദാറ്റ് ഇസ് 0.693 ഡിവൈഡഡ് ബൈ ലാംഡ. സോ ഡിഫറെൻറ്റ് റേഡിയോആക്റ്റീവ് ന്യൂക്ലിയഡിൻ്റെ T half ആണ് ഞാനിവിടെ ഇൻക്ലൂഡ് ചെയ്തിട്ടുള്ളത്. പൊളോണിയത്തിന് 3×10⁻⁷ seconds ആണ്. ഫോസ്ഫറസിനാണെങ്കിൽ 14.3 days ആണ്. അപ്പോൾ ഓരോത്തിനും യൂണീക്ക്, ഓരോ എലമെൻറ്റിനും യൂണീക്കാണ്. ദാറ്റ് ഇസ് T half. It is constant for each radionuclide given by the equation T half is equal to 0.693 divided by 5.